someone was also asking about how to use this Vassarstats program. So for today's example, we're just going to make up some numbers. We're going to go to Vassarstats. You can just Google it. You can already go ahead and come down here to the t-test, since that's what we're going to be using. We had all independent samples, no reason to pair or correlate them. And let's say we had some random numbers for rainforest, maybe 1.8, 0.7, 0.4, 0.9, 1.2. And then let's say we were doing some average desert leaf thicknesses, and of course they tended to be a bit thicker at 4.2, 3.8, 4.1, and let's say maybe 2.9, and then, I don't know, 3.3. So you get the idea, right? So here we have our averages. Once again, don't come down to the following line, stay up on your last data point entry. Click calculate, we're going to run a bunch of numbers. So now we're going to scroll down, we're going to look for specific values. You can see here, if we look at the differences in our means, then we have a significant difference in our p-values. And these are going to be really important because we're going to come back down to our means. Wow, weird. The average for the rainforest plants that I randomly made is just 1. Then we have the standard error, which are these numbers right here under the 95% confidence intervals. We have our p-value, which is less than 0.001. This, of course, doesn't matter in this case because here we have the normal distribution data, and this is a t-test that assumes unequal sample variances. That just means that our data is not normally distributed. So depending on what we have, here we're assuming normality. In this case it doesn't matter because they're both extremely significant differences. So if you're going to make a chart out of this, you need these two averages and you need these standard errors, which are the main numbers that you'll need. And that's how you run a t-test using Vassarstats